What up, your boy C. Rizzy coming at you with Unit 5, Lesson 6, Inequalities in One Triangle. Our central question is, how do you solve problems that involve measurements of a triangle? And our objective is to use inequalities involving angles and sides of a triangle. Our essential understanding is that the angles and sides of a triangle have special relationships that involve inequalities. So our first special relationship is just a corollary to the exterior angle theorem, which just, if we remember what the exterior angle theorem said, that the measure of angle 2 plus the measure of angle 3 equals the measure of angle 1. So basically, all it says is that if 2 plus 3 equal 1, then the measure of angle 1 must be greater than the measure of angle 2, and the measure of angle 1 must be greater than the measure of angle 3. Just makes sense. So our first and real important theorem of this section states that if two sides of a triangle are not congruent, so basically if it's a scalene triangle, then the larger angle lies opposite the longest side. So what it says here is that if XZ is my longest side, then angle Y is going to be my largest angle out of all of the angles. It's going to be greater than X, it's going to be greater than Z, it will be the longest or largest. So what does that look like? So for instance, here's the triangle. List the angles in order from smallest to largest. I don't know what the angle measure is going to be, but I can tell you from side lengths which angle is going to be bigger than the other. So to do this, I'm going to first list my sides from smallest to largest. So 2.7 is less than 4.3, which is less than 5.8. So those are my sides, shortest to longest. Okay. Now, one thing to note that you should notice is that 2.7 is LK, 4.3 is KM, and 5.8 is LM. So 2.7, the smallest angle is going to be opposite 2.7, which is angle M. So angle M is going to be less than 4.3 is opposite angle L, which is going to be less than 5.8, which is opposite angle K. Less than. Let me do these in black. Angle M is less than angle L, which is less than angle K. So you can also notice, though, that angle M is opposite LK. Notice that M is not in LK, so you know which angle is opposite. Angle L is opposite KM. Notice KM doesn't have an L in it, so that's what it's opposite. So those would be the angles. So angle M is shorter than angle L, which is smaller than angle K. So in this one, okay, I know that it says list my angles in order from smallest to largest. Well, I already know that angle E is my greatest angle because it's obtuse. Okay, you know your obtuse angle is always your greatest. So then I look at the side lengths. I know X is smaller than 3X. So if X is CE, then what's opposite X is going to be angle D, which is going to be less than 3X, which is ED, and what's opposite ED is angle C. So angle D is less than angle C, which is less than angle E. Now the reverse holds true also. If I know my angle measures, I can figure out what are my longest sides or my shorter sides. So same thing, list the sides of each angle in order from shortest to longest. So doing quick calculations, I can figure out what my other missing angle is. Number 15, 180 minus 75 minus 45 is, I don't feel like doing this in my head, minus 75 minus 45 is 30. Okay, so I know, same thing, except this time I'm going to list my angles from shortest to shortest to longest, so smallest to largest. Okay, because there's no distance. So 30 degrees is smaller than 45 degrees, which is less than 75 degrees. So again, do what's opposite. This is angle M, this is angle O, this is angle N. So what's opposite angle M is ON, is going to be less than what's opposite angle O, which is MN, which is less than what's opposite of angle N, MO. Same thing here. Okay, again, quick calculations. 180 minus 110 minus 28 leaves me with 42. So I'll list them in shortest, smallest to largest. 28 is less than 42, which is less than 110. This is angle G. This is angle H. This is angle F. So 28, its opposite side is going to be HF, is less than GF, which is less than GH. Okay, so for three segments to form a triangle, their lengths must be related in a certain way. Notice that only one of the sets of segments below can form a triangle. The sum of the smallest two lengths must be greater than the greatest length. And I'm going to talk more about this on Monday. There'll be an extra credit question. So, triangle inequality theorem states that the sum of the lengths of any two sides of a triangle must be greater than, strictly greater than, the length of the third side. So any side. So sometimes it's easier just to mark this A, B, C. So A plus B has to be greater than C. B plus C has to be greater than A. And C plus A has to be greater than B. So an example, can a triangle have the side lengths given explained? So we have to do this 3 times, A, B, and C. So 2 plus 6 has to be greater than 9. 6 plus 9 has to be greater than 2. And what's my last one? 2 plus 9 has to be greater than 6. So let's see if that's true. 2 plus 6 is 8. Is 8 greater than 9? Nope. 6 plus 9 is greater than 2. That's true. 2 plus 9 is greater than 6. That's true. Since one of these is not true, it all fails. So in A, no, it cannot be the side lengths of a triangle. Let's try B. 4 plus 6 has to be greater than 9. 6 plus 9 has to be greater than 4. And 4 plus 9 has to be greater than 6. 4 plus 6 is 10. That works. 6 plus 9 is 15. That works. 4 plus 9 is 13. That works. So yes, this can be a triangle. So if one fails, they all fail. They all must be true. So lesson check. Which side is the longest? So I know that this angle here is going to be 95 degrees, which is obtuse. So BC must be my longest side. My smallest angle must be opposite 4. That's got to be angle C. And can the triangle have side lengths of 4, 5, and 10? Why or why not? And we'll try it out. 4 plus 5 has to be greater than 10. 4 plus 10 has to be greater than 5. And 5 plus 10 has to be greater than 4. 4 plus 5 is only 9, so that fails. So these cannot be the side lengths of a triangle. All right, that's all for me.